Okay, problem 4-32, we are solving for the indicated variables. So in problem A, we are solving it for y, which is right here. So I basically want to get that by itself. So in that problem, 5x minus 3y equals 12. I'm going to remove the 5x from this side. I'm going to undo it right now as being, it is a positive 5x. I'm going to subtract 5x from both sides. That leaves me with a negative 3y equals a negative 5x plus 12. And now to get y by itself, I'm going to undo the multiplication here. So I'm going to divide by a negative 3. I'm going to divide everything by a negative 3. I now have y by itself. It is y equals a positive. A negative over a negative makes a positive. A positive 5/3 x minus 4. And problem A is complete. On to problem B. Alright, B looks much more confusing because it's just variables. There's nothing else here. But what we need to realize in this problem, F represents a number, G is a number, M sub 1 is a number, M sub 2 is what we're trying to solve for. We want to get that by itself. And R squared is just a number. So we're going to work with this as if they were all just numbers. It's the exact same process. So right now, when I look at this problem, I want to get m squared by itself. So F equals G times m sub 1 times m sub 2 divided by R squared. Right now, R squared is dividing what we want to solve for. So to undo that division, I'm going to multiply both sides by R squared. R squared over R squared makes a giant 1. So I now have R squared times F equals G times m sub 1 times m sub 2. These two things here, G and m, are both multiplying m sub 2. So to undo that multiplication, I'm going to divide by both of them. You could do this in one step like I'm doing it now, or you could divide them in two different steps of dividing just the g's first and then just the m1s. But when I divide that, g over g makes a giant 1, m1 over m1 makes a giant 1. So now all I'm left with is m sub 2. So my answer here then is m sub 2 equals this, R squared times F over G m sub 1. And on to problem C. So the first thing in problem C that I'm going to do is take a look at a fraction, and I'm going to do fraction busters to get rid of that. I'm solving it for m, so I want to get this m by itself. So fraction busters, if I have e equals 1/2 mv squared, I'm going to multiply everything by 2. Distribute it here, put a 2 there. Distribute it here, and I put a 2, multiply by 2 there. I don't distribute it anywhere else over here because those are all being added. If there was pluses or minuses between any of these, then it would be different. I'd distribute to all of them. However, there is not. So all I'm doing is distributing the one time to that. So I now have 2e equals mv squared. I now want to get the m by itself, which is being multiplied by v squared. So to undo that, I'm going to divide both sides by a v squared. And v squared divided by v squared makes a giant 1. So all I have left is m. So I have m equals 2e divided by v squared. And lastly, problem D. I am solving this for y. So the first thing I need to do is get rid of what's adding it, which is this entire thing. So I'm going to have x plus 4 squared plus y minus 1 squared equals 10. I'm going to subtract this whole thing, x plus 4 squared, from both sides. That gives me y minus 1 squared equals 10 minus, and then in parentheses, x plus 4 squared. Now, the next thing I want to do is undo this square, so I'm going to take the square root of both sides. Now, if you think of this original equation here is the equation of a circle. So when I take the square root, I'm going to end up getting y minus 1 equals the square root of 10 minus x plus 4 squared. However, if I graph that on a calculator, it's not going to give me the circle. It's only going to give me the top half of that circle. I need the bottom half as well, and that is why I need to have a plus and a minus there. So I have both the positive and the negative. This is the positive, that is the negative. That's just a rough sketch. It's not actually where it would be located on the graph. However, I'm just trying to make the point. Now, the last thing I need to do is remove the negative 1, so that is being added to the y, so I'm going to add a positive 1 to both sides. And my final answer then is y equals 1 plus or minus square root of 10 minus, in parentheses, x plus 4 squared. So you may wonder why I did not multiply this out, and you definitely can. But if you multiply that out and then combine like terms, you still cannot take the square root, so it can just stay where it is.